Hello friends, and welcome to my video. In this video we are going to talk about time, speed and distance. And this topic I am going to cover in series of videos, and this is the first part of that series, and I hope you would enjoy doing time, speed and distance with me. This video focuses on very elementary aspects of time, speed and distance, and let us see and explore it. Okay, the very first thing that we will talk about is the basic relation between time, speed and distance. So what's the basic relation between time, speed and distance? We all know, most probably we all know, and even if you don't know, there is nothing to be worried about. The basic relation is speed is equal to distance upon time. What we understand from this is speed is the rate at which we are covering the distance. The rate at which we are covering the distance. As far as aptitude is concerned, we don't need to be worried about the theoretical definitions of speed, distance or time. They are practically meaningless if you just understand what exactly speed is. It is just simply measure of distance per unit time. That's it. If you know this much, that is it. You don't need to cram it, you just need to understand it. That's it. And so the first thing, now what exactly does this relation mean? Obviously, if you are given distance and time, you would be able to calculate speed. If you are given speed and time, you would be able to calculate distance. But we need to derive some fundamentals. We need to derive some fundamentals from this relation. So the very first observation, which most probably you must have done, is speed is directly proportional to distance, provided time remains constant. So when time is constant, speed is directly proportional to distance. Distance is directly proportional to time. Distance is directly proportional to time, provided speed remains constant. How? Suppose this is distance, so if you cross multiply this, then time would go over here. Then if speed is constant, then distance and time would be directly proportional to each other. And the third one is speed is inversely proportional to time, provided distance remains constant. Now these are the three main tools that we get from this relation, and these tools are really going to help us a lot in solving questions and deriving further results that we will see in series of videos. So now let us understand each of them. These are simply mathematical representations, but we have to make this thing real to understand it well. Speed is directly proportional to time, provided distance remains constant. What exactly does this mean is, suppose you are given that you have, say, 1 hour. So you have 1 hour and you have to travel in 1 hour. So speed is directly proportional to distance. So for 1 hour, if you will travel at some speed x, then you may cover some distance small d. Okay, now you travel at some increased speed x plus y, then your distance is sure to increase by, say, d plus d1. Let us make it live. Suppose you have 1 hour and your speed is 1 kilometer per hour. Okay, your speed is 1 kilometer per hour. So your distance would be 1 kilometer. You will travel 1 kilometer in 1 hour. If you put the values over here, you have 1 hour, that is time is equal to 1, and speed is also 1 kilometer per hour, then distance would be obviously 1 kilometer. So this is for first case. Now suppose you increase your speed to say 2 kilometer per hour, and your time still remains fixed, that is 1 hour, that is constant. Then what would be the new distance? It would be 2 kilometer per hour. So if you have fixed time, that is constant time, then if you increase the speed, the distance covered would be increased, and if you decrease the speed, this distance covered would be decreased. In the same way, you can think it the other way. If the time is 1 hour, and if you have to cover more distance, you have to increase the speed, and if you have to cover less distance, you have to decrease the speed. That is first thing that we learn from this fundamental, that is speed is directly proportional to time. Now for the second fundamental, that is distance is directly proportional to time, uh, provided speed remains constant. Distance is directly proportional to time provided speed remains constant. So say your bike is fixed to be driven at say 25 kilometer per hour, and distance is directly proportional to time. Distance is directly proportional to time. So if you travel for 1 hour, you will cover 25 kilometer. Now suppose instead of 1 hour you travel for 2 hours at a speed of 25 kilometer per hour, you will cover 50 kilometers. Okay, and in case you travel for half an hour, you would cover 12.5 kilometers according to this relation. So still you can see that as time is increasing, distance is increasing for the given speed, and as time is decreasing, distance is also decreasing for the given speed. So in this way you can interpret this second proportionality. Third proportionality is speed is inversely proportional to time provided distance remains constant. So suppose you have to cover distance of say 60 kilometer. Okay, and now initially for the first time you travel the 60 kilometer at a speed of 5 kilometer per hour, then time taken would be 12 hours, obviously according to this relation. So okay, now for let me call this S1 and T1. Now again you travel those 60 kilometer at a 10 kilometer per hour, then time T2 would be 6 hours. If you can see, as the speed is increasing, time is decreasing, and as this and vice versa. So if you increase the speed, the time required to cover the same amount of distance would decrease. So in that case, speed and time are inversely proportional to each other. These are the three basic proportionalities that we need to understand, and later move on to the next topic. Okay. Now the next thing that we need to talk about is units. So what are units of speed, distance and time? Speed is equal to distance upon time. Now distance can be in meter, it can be in kilometer, or it can be in centimeter. Time is in hours or seconds or minutes, and accordingly speed can be in meter per second, kilometer per hour, or meter per minute. Well, it can be the combination of any of these units, but these are the most probable units. most probably used units. Now at times we need to convert from meter to kilometer and from seconds to minutes. That we all know that 1 kilometer is equal to 1000 meter, and mm, 1 hour, this is hour, 1 hour is equal to 3600 seconds. So 1 kilometer per hour is equal to 1000 meter upon 3600 seconds. Cancel this out, and this would be 25 by 18 meter per second. So whenever you want to convert any given kilometer per hour into meter per second, you simply have to multiply it with 5 by 18. Say you have 36 kilometer per hour. You want to convert it into meter per second. You simply have to do it. You simply have to multiply it with 5 by 18, and 18 1 by 18, 18 to the 36, and it will be 10 meter per second. Same way, if you want to convert meter per second into 1 kilometer per hour, you simply have to multiply it with 18 by 5. Simply have to multiply the digit with 18 by 5. Why? Because 1 meter per second would be equal to 1 by 1000 kilometer upon 1 upon 3600 hours. So this will be equal to 1 upon 3600 upon 1000, and 5. So your answer would be 18 by 5. So 18 by 5 and 5 by 18 are conversion factors. And you need to remember them. So this was all about units, a brief talk about units. Now let us see our next concept. The next thing I would wish to talk about is average speeds. Average speeds. Now what is average? The average is basically sum of all the observations upon a number of observations. That is some weird mathematical definition. But when it comes to speeds, distance and time, this thing becomes critical because questions regarding average speeds can be tricky. So if you know the clear idea about average speeds, those questions becomes very easy. Let us understand. Say I am traveling from place A to B. I am traveling from say place A to B. Let us consider it a bit other way. This is I and this is you. We both are traveling from place A to B. Okay, not together, not necessarily together. Just understand that at some point of time I am going from A to B, and at some other point of time you are going from A to B. Now it is possible that while going from A to B, which is say 100 kilometers apart, for first 60 kilometers I might be traveling at say 10 kilometers per hour due to some excessive traffic congestion for my first 60 kilometers. Okay, but for remaining 40 kilometers I could travel at say 30, or maybe let us say 40 kilometers per hour. Okay, let me erase this. Sorry. Okay, so for first 60 kilometers, and this is for last 40 kilometers, then what would be the total time that I would have taken is for this 60 kilometers I would take 60 by 10, that is 6 hours. Okay, and for this 40 kilometers I would take 40 by 40 is equal to 1 hour. Then the total time would be 6 plus 1, 7 hours. Okay, now let us talk about you. You travel, say, first 30 kilometers at speed of 5 kilometers per hour due to extreme traffic congestion or whatever reasons. And for the remaining 70 kilometers, you could travel at about what number should I choose? Say 35 kilometers per hour. What would be the net time? For the first 30 kilometer, you would have spent 6 hours, and for 2 hours. So net time would be, that is T2 for 70 kilometers. So net total time would be 8 hours. So you took 8 hours to travel the distance of 100 kilometers. Now what would be your average speed? My average speed is, that is AI, would be 100 upon 7. And yours would be 100 upon 8. Now it is not necessary that it means that at all the point I was ahead of you. Because I am taking less time does not mean that I was always ahead of you. There is a possibility that while in those 100 kilometer, at some point of time you were steady, at some other point of time I was steady, at some point of time you were ahead of me, anything. Or here we have not considered that our tire got punctured or our vehicle broke down or anything, but all these things are accounted while calculating the average speeds. The time, whatever time is spent is actually distributed equally over the entire distance. So when you reach there and at your home, somebody would ask that at what speed did you come? Whatever answer you give usually is average speed. Say whenever I go from Ahmedabad to Baroda, it usually takes 2.5 hours. And whenever I reach Baroda, someone would surely ask that, okay, at what speed did you come? And I would say around 100 kilometer. So 100 kilometer per hour speed. So it is not necessary that on my speedometer my arrow, my pointer was fixed at 100 speed. It can be at a speed of say 40 at some point of time when I was in heavy traffic, and it can be at a speed of 120 at some point of time when I was on expressway or highways. So that is what is all about average speeds. So average speeds are simply the average, they are not the actual numbers. So you can't say that if average speed is 100 upon 7, so that person was traveling at 100 upon 7 at all the point of time. No, it is not possible. At some point that person travels at more speed, at some point a person travels at lesser speed, but that its average turns out to be this value. So that's important to know about average speed. The next thing that we would talk about is uniform speed. Uniform speed. Now let us say I start traveling from place A again to place B. Okay, and as soon as I start, this is my speed dial. I fix my pointer to say 100 kilometer per hour. What I actually mean is I am traveling at a fixed speed of 100 kilometer per hour. Let us assume some ideal condition. There is no traffic between A to B. There are no bumps, nothing, no obstacles, so that I can, and the road is extremely straight. So I don't have to take any turns or I have to reduce speed for any reason. Then I am traveling at constant 100 speed 100 kilometer per hour. So such a kind of drive is called uniform speed. Speed is remaining uniform, that is why it's called uniform speed, and that's called constant speed. Okay, now assume the I don't know it. Yeah, this was about me, that is I. Now let us consider your case. You are traveling from A to B at 200 km per hour, again fixed or uniform or constant. All of them means the same. So you are traveling at 200 km per hour from A to B. That is, your dial is fixed at somewhere at 200 km per hour. Okay, so this is what I call uniform speed. That is, your speed remains constant over the entire distance. Okay, now we will have some interesting observation about the uniform speed on this video. I just told you that I am traveling at a speed of 100 km per hour, and you are traveling at a speed of 200 km per hour. Now you will realize why I was talking about those three fundamentals in such a detail. So I am traveling at 100 km per hour and you are traveling at 200 km per hour. So suppose n represents number of hours, distance covered by me, that is I, and distance covered by you. Okay, so in first hour I will cover 100 km and you will cover 200 km. In first half hour, that is, this is for first 1 hour. Now let us talk about first half hour. You would cover 50 km and sorry, I would cover 50 km and you would cover 100 km. For second hour, that is at the end of second hour, that is in time of 2 hours, you would cover, sorry, I would cover 200 km and you would cover 400 km. Let us talk about third hour, and I'm not going to proceed anymore because we will understand and we will see one very important result or observation from this. I would cover 300 km and you would cover 600 km. Now what is the ratio of your speed to the my speed? That is, yours and mine's constant speed. Mine's constant speed, that is 1 upon 200. The answer turns out to be 0.5 or 1 by 2, whatever. Now at each point of time, if you will understand, this ratio of distance covered is also going to remain 1 by 2. 1 by 2, 5 by 10 is again 1 by 2, 200 by 400 is again 1 by 2, and 300 by 600 is again 1 by 2. What we can conclude is, when two people are traveling at when two people are traveling at different fixed speeds for same period of time, ratio of their speeds equals to ratio of their distance covered. Okay, so this is what we get when you and I both were traveling at some fixed speed and for same interval of time. The ratio of the distance to be covered has remained constant. So this is a nice observation, and this is one of the important results that we are going to apply in our sums at some point of time when we will solve the examples on speed distance of time. Now Now, why is this happening and why this interesting result has emerged? Let us understand this with the help of that proportionality. I just told you that speed is equal to distance upon time. Now we took different values of n as n equal to 1, 2, 1 by 2 and 3. So for first hour, that is value of time would be 1 hour. Then time becomes constant, then speed is directly proportional to distance. Now for my speed is di and my distance is my speed is si and my distance is di, and your speed is sy and your distance is dy. So si upon sy would be equal to di upon dy. This relation is going to hold true for any case, that is for any value of time, because time is ultimately becoming constant, and from this proportionality we are getting this result, and this indeed is an interesting result and an important one too. Next concept we are going to talk about is the concept of relative speed. Say this is a straight path and we are I am chasing you, so this is me and this is you. Okay, this is you and you are running at 10 kilometers per hour and I am running at say 12 kilometers per hour. Obviously I have to run faster than you, then and only I can catch you, right? So I am running faster than you. Yes, I am strong, I am better runner than you. Anyways, so now this speed of 10 km per hour and 12 km per hour is with reference to some stationary object. That is, suppose there is some person standing over here and he is looking at both of us and he is standing, he is not moving. So to him I appear to be running at 12 km per hour, I appear to be running at 12 km per hour, and you appear to be running at 10 km per hour. But what I am interested in knowing is what are the speed at which we see each other running. So you are already running at 10 km per hour in this direction. You are already running at 10 km per hour in this direction. Okay, and I am running behind you at a speed of 12 km per hour. So the net effect would be such that at what speed I would see you running is 10 minus 12, that is 2 km per hour. 12 minus 10, that is 2 km per hour. So our relative speed is 2 km per hour. So what it means that I am running at 2 km per hour faster than you. So if you are running ahead and if you see behind, then you will see that I am coming towards you at a speed of 2 km per hour. And when I see you, I will see that I am moving towards you at a minus 2 km per hour. That is because this minus sign shows that distance between us is going to decrease because my speed is more than you. So now this minus and plus is not important over here. Thing you need to understand is the concept of relative speed. Why we subtracted this? That is because we are moving in same direction. So the net effect would be this minus this, and that you can remember also, and soon you will realize it is a fundamental concept. Now suppose you decide that okay, no matter, even if you're trying to chase me, now I am going to chase you. So you are just change your direction. Still you keep your speed the same. So now we are traveling towards each other. So what you will see is 12 plus 10. So we will see each other traveling towards each other at 22 kilometers per hour. So our relative speed will increase. So when we travel in same direction, our relative speed would be subtraction of our speeds, and when we travel in opposite directions, as in this case, our relative speed would be addition of the two speeds. I would just like to give you one example to make it clear. Have you ever observed that you are going on some highway? You are going on some highway road, and this is your car. I know it really does not appear like a car, but you are moving in this direction, and some other car is coming on the road next to you in this direction. If you will be sitting over here and look out of the window, and you see this car moving from here, you will see that the car moves at tremendous high speed. Why this happens is because you are traveling in this direction and this car is coming in this direction. The speed at which you will see this car would be much more than the speed at which this car would be actually running. Say you are traveling at 50 km per hour and this car is traveling at 60 km per hour. But you would see this car traveling at 110 km per hour. That is because both the speeds get added, and that is what you see when you look out of the window. Okay, now suppose there is one car over here and you are following that car. Now this car is really pathetic. I need to draw a bit bigger. Okay, again this car is travel at 60 and you are following it at, sorry, this, okay, 50. So what will happen is 60 minus 50, so you will see that this car is traveling at 10 km per hour. You will see that this car is traveling at 10 km per hour. So with respect to you, this car will cover 10 kilometers each hour. Now again, an interesting observation to be noted about this is, let me just make few doodles again. Car, another car. This is 60 and this is 50. N represents R. Okay, so for first R, this is car A and this is car B. Car A would travel 60 km, whereas car B would travel 50 kilometers. This is distance covered by car A and this is distance covered by car B, and the difference between the distance covered is 10 km. For the second R, this will be 120 km and this will be 100 km. Okay, difference would be 120 minus 100, that is 20 km. For third R, this will be 180 km and 150 km. So the answer is 30 km. So for each hour, if you observe, this car is moving farther away ahead of this car by 10 kilometers, and that is precisely the relative speed, that is 60 minus 50 is 10 kilometers per hour. Why is this happening is, for this car is moving ahead at a 10 kilometer per hour. So this car, we see that okay, this car is going away from me at 10 kilometers each hour. Okay, so this is all about relative speed, and such observations can be seen even if a car are traveling in same direction or even in the opposite direction. So that's all about the basic elementary ideas of speed, distance and time. I hope you found this video useful, and we will see some other concepts and sums in the upcoming videos. Thank you.